Good afternoon, everyone. Nice to be with you again, and we expect to have a nice conversation today, and hopefully some of this information will be useful for you. Coming to you from beautiful, sunny, and hot Denver, Colorado. It's nice to talk to everybody today. We're going to be talking about improving fire alarm intelligibility through technology, and part of technology is also design. So we're going to look a lot at how we design systems and some good design tips. So hopefully this will be good and practical for your information. So we're going to focus on three things in today's presentation. We're going to look at the code requirements regarding intelligibility. We'll look at some practical suggestions for improving loudspeaker design, including 6 design tips that we think are very important as designers lay out systems. And we're going to end by looking at some new technology in fire alarm loudspeaker design, some of the newer products that are on the market, and hopefully open up your minds to some new items that are out and on the market. Start with a disclaimer, since I do sit on an NFPA technical committee, specifically NFPA 72, the ECS chapter. I'm not speaking on behalf of NFPA. We certainly encourage you to buy a copy of NFPA 72 if you have not done so. That's where you can receive the official position. Also, we're going to be featuring products, both pictures and specific products. They are for informational purposes only. It's not an endorsement. I'm not selling anything. I don't get a commission from doing any of this. We're really just showing you some of these products. You know that they exist, and then you can do further research and see if it's something you want to include in your designs going forward. So let's start first with the code requirements regarding intelligibility. Now, if you joined us a couple of weeks ago when we talked about acoustically distinguishable space, we talked about some of these requirements in a little bit more detail, but this will just be a short review of some of the intelligibility requirements from NFPA 72, and we're going to be using the 2019 edition. I know some of you in your local jurisdictions may not be on that edition, but this will show you at least where the code is going if you're not already on that edition of the code. Now, since the 2010 edition of the National Fire Alarm Signaling Code, much has been written and discussed regarding fire alarm and emergency communication intelligibility. The 2019 edition of NFPA 72 contains some 156 references to intelligibility, with almost 30 of those being in the body of the code. So this is fixed firmly in the code itself. First and foremost, intelligibility became a defined term. That defined term is found in Chapter 3. It's the quality or condition of being intelligible, which is kind of a silly definition. But if you look up intelligible, which is also in the code, it's to be understood, comprehensible, or clear. So that's really what we're talking about. The whole point of voice communications is for it to be understood so that we can make proper decisions and act on it. Additionally, we had a brand new term that came into the code in 2010, and that was our acoustically distinguishable spaces, which again, we talked about in detail during our last presentation. And if you weren't able to attend that, you can reach out to Anne-Marie and she'd be glad to get you hooked up with that as I believe it was recorded. This term, acoustically distinguishable spaces, is now used some 10 times in the 2019 edition, and it refers to a system designer being responsible for defining and grouping specific areas of each facility with acoustically similar spaces and the voice intelligibility that is required in each one. And we'll briefly discuss, do a quick review on ADSs. Chapter 18 also makes it clear that pre-recorded and manual voice messages shall be intelligible per the requirements in Chapter 18. It also makes clear that this is measured usually in subjective, qualitative ways rather than quantitative measurements like an STI or a CIS meter scoring. This is important because often it's missed. Also, often AHJs may say, well, you need to give me a measurement of your intelligibility, and that's certainly possible, and we'll talk about how that's done. But the code itself is right now only requiring subjective or qualitative intelligibility. It's really somewhat a person's opinion rather than a quantitative measurement. Now, in Chapter 18, it also makes it clear that voice messages or the voice message portion of a pre-recorded tone voice message shall not be required to meet the sound pressure levels required in Chapter 18, like the 15 dB above ambient for public mode or the 5 dB above ambient for private mode. This is so that the voice message can be intelligible. Since voice is composed of modulated tones, a voice signal that's subjectively judged to be equally as loud as a tone signal will actually produce a lower dB reading than that of the tone signal. So when we do measurements of our audibility, we want to measure the tone portion of the message. When we are trying to measure intelligibility, we're listening to the voice portion of that measurement. So two different ways to look at really the same evacuation signal. Additionally, a system designer is required now to spell out each acoustically distinguishable space and which require and which do not require voice intelligibility. Now, all ADSs must be documented. That's told, we received that in Chapter 7, and they must be shown on the design documents. It also clarifies that intelligibility may not be, and actually is not, required in all ADSs, even though voice loudspeakers may be used as the audible notification in those spaces. And really, that's the whole point of an acoustically distinguishable space, is to say which spaces will have full intelligibility and which will have something less than that. Now, all types of systems providing emergency messages, including fire alarm and emergency communication or mass notification systems, must be capable of producing voice intelligibility regardless of whether this is via a pre-recorded message, a synthesized message, or a live voice message. Again, whether that live voice is produced by a live microphone, a live telephone handset, or some kind of live radio input or other way. Then, in the 2016 edition, for the very first time, it allowed the use of non-listed loudspeakers in order to achieve the intelligibility requirements of the system designer. Now, this was quite a shift, and we're going to look at this requirement in a little bit more detail in just a few minutes. Now, Chapter 24 contains most of our information on intelligibility and certainly voice systems, and it continues to make it more clear that all loudspeaker layouts, which are required on the design documents, shall be designed to ensure intelligibility and audibility. In order to accomplish this, it states that intelligibility shall first be determined by ensuring that all areas of the building have the required level of audibility, or how loud is it. This allows a designer to properly provide required audibility throughout a building while properly designing acoustically distinguishable spaces with required intelligibility requirements. Now, today's presentation will include some good design suggestions to provide a proper loudspeaker layout and design. And finally, Chapter 24 makes it clear that in order to provide intelligibility, it may, and usually is, required to deactivate things that interfere with intelligibility. This requires fire alarm systems and emergency communication systems to have the ability to deactivate any and all audible or maybe even visual notification appliances that interfere with system intelligibility, regardless of the source of those interferences. Thus, it's often required to shunt paging systems, audio or advertising systems, maybe multimedia or other audio-visual sources in order to provide a clear, intelligible message. And the best example of this is like a bar or a nightclub where you would need to shunt the ambient audio, turn it down or turn it off in order to hear an emergency message at the proper levels. And that's probably the best example of that shunting or anything interfering with the message. Now, that's just a short review of some of the most critical code requirements for intelligibility that's in NFPA 72, but there's a few more other items we want to discuss to round out this discussion of how we do this. First, with the 2010 edition, some global changes were made that sound a bit funny on the surface, but are important for you to understand. It was a change regarding how two specific terms are used throughout the code book. First of all is the term speaker. Now, speaker is a person talking, so I am a speaker. A loudspeaker is a mechanical means by which voice messages are transmitted. And this term is used some 140 times in the 2019 edition of NFPA 72. Now, we know that because we literally had to go through the entire book and find every place that it said speaker and determine, are they talking about a person speaking, or are they talking about a mechanical means which voice messages are transmitted? And wherever it was the latter, they changed it to loudspeaker. So yes, for those of you not on NFPA technical committees, this is what we spend hours doing, and it just fills our day with these kinds of things. Now, this change also meant that we had to change our wide area or outdoor voice systems. We used to call those high power speaker arrays, and now we call them high power loudspeaker arrays, so HPLAs instead of HPSAs. So for those of you doing wide area mass notification, that's important to note as a change in the 2019 edition. Now, we mentioned a few minutes ago that a change was made in 2016 regarding the use of non-listed loudspeakers. So let's look at that in just a bit more detail. In the 2010 and 2013 edition of NFPA 72, there was no allowance for the use of non-listed loudspeakers in a fire alarm or emergency communication system. Now, interestingly, there was this provision in Chapter 24 that allowed the use of non-listed detection devices if required by an emergency response plan. Now, this included items that at the time met the emergency input needs of an ECS or MNS. Things like panic buttons or weather monitoring inputs or shot detection devices that at the time were not listed. However, this did not address output notification. However, it was this language that really became the basis for a significant change. So with the 2016 edition, allowance was made, finally included, to allow the use of non-listed speakers where no listed loudspeaker exists to achieve the intelligibility requirements of the code. Now, this was an open acknowledgement of the relative limitations of listed fire alarm loudspeakers at the time and the length of time and cost involved in listing speakers to meet UL life safety requirements. Now, this language is a little wonky, for lack of a better word, because clearly some loudspeakers could be said to exist, but we changed it in the 2019 just to be even clearer. So it now says where listed loudspeakers do not achieve intelligibility requirements of the code, then you can use non-listed loudspeakers. This makes it much clearer that to allow non-listed loudspeakers where listed speakers, even if they're not non-traditional fire alarm speakers, exist, but they don't meet the intelligibility requirements for the situation. And this is really quite a shift if you think about it, because there's very, very few things in the code that allows you to use a non-listed piece of equipment. We're going to take a look at this a little bit later from a different aspect and say what is being done to provide listed speakers that we've never had before. We thought it would be good now to provide a quick reminder of what a fire alarm loudspeaker is listed to. So fire alarm loudspeakers in the United States are listed to UL 1480, and that is the speakers for fire alarm and signaling systems, including accessories. It's the name of that. The current edition version is edition 6 from 2016, and here in the US it uses a reverberant chamber test. It's for speakers that are 300 volts or less, whether for indoor or outdoor use. It does not cover speakers intended for commercial or professional audio applications. Those are covered by some of the other UL standards that you see listed on your screen. And it's many of those speakers that are the so-called non-listed speakers that can be used by NFPA 72 systems now. Products in Canada must be listed to ULC S541 standards. It's a very similar standard to UL 1480 with a difference. It uses an anechoic chamber test. In general, anechoic speaker output ratings are typically more representative of actual installed sound output, like as we hear it. Sound pressure levels in a reverberant room are typically lower than for the same sound source in an anechoic chamber. This is because the reverberant results include an acoustic averaging of the response at all angles. View it as like an umbrella, the way it measures the sound like an umbrella around the device. Whereas anechoic readings are usually taken on access, so kind of the maximum output of the device. Now, most manufacturers list both ratings on the data sheet, and sometimes that causes a little confusion, like which one should I use? But per the UL 1480 standard, in the United States, we use that reverberant chamber test in that listing, and in Canada, it uses the anechoic. But anechoic is a bit better representation of the sound pressure level that you're actually going to perceive when you're out in the field. Now, UL 1480 looks for specific and minimum audibility outputs of appliances.
Okay.
Specifically, it requires 75 dB or greater measured at 1 watt at 10 feet from the device. So it's a very specific test at from that sound source. They use a pink noise generator, and it measures a range from 4,000 hertz to 400 hertz to 4,000 hertz. Now, this is very similar to the testing performed on non-voice fire alarm devices like horns and chimes. It's important to note, however, that human speech differs greatly from a tone. Human speech is actually one of the most complicated things that we can study. Human speech ranges in 7 octaves from 125 hertz to 8,000 hertz, with the majority somewhere in the middle. Now, sounds that make up words are created by amplitude modulation of those frequencies. Amplitude modulations of speech patterns are seen as the peaks and valleys of the waveform, usually ranging from 0.63 hertz all the way up to 12,500 hertz. Consonants generally have the lowest power contribution to speech, but they're extremely important to intelligibility. Consonants like the T and the S sounds are relatively high in frequency, but of a very short duration. Vowel sounds carry most of the power of our speech signal. So you can see right away, we kind of see a difference, right? We see a difference between how a loudspeaker is listed and how we actually hear speech. We'll come back to this when we talk about some of the new technology that's on the market. Now, while not code requirements, there are a few other items that should be noted to any fire alarm or ECS system designer to help you along the way. These could be considered so-called essential, even if they're not code required. The first is NEMA SB50. It's the Emergency Communications Audio Intelligibility Applications Guide. Now, the latest edition is 2014, and it's available at nema.org for a free download after registering, or for a small fee if you would like the printed edition. It nicely includes a basic explanation of Ohm's law and the decibel, the nature of speech, kind of like we talked about on the last slide, room acoustics, speaker basics, including wall versus ceiling speakers, which we're going to talk about in a few minutes, and a discussion of speech intelligibility. Now, this is a great document, and especially great because it's free. Really, this is an important document to be aware of. Now, contained with NFPA 72 itself is a very important annex. It's Annex D on speech intelligibility. Now, this is available in both the NFPA 72 codebook and in the handbook. It was added in the 2010 edition and has been updated with each edition since then. Now, it's based on the NFPA Fire Protection Research Foundation project in October 2008, and it includes guidance on the planning, design, installation, and testing of voice communication systems. This includes specific test protocols, limitations and concerns, information about defining acoustically distinguishable spaces, and the differences and testing methods of quantitative measurements like your STI or CIS or Alcon score. So if you have an AHJ or maybe a military project or other project that requires quantitative measurements of intelligibility, you need to go to Annex D. It is going to be the one place that's going to tell you how to actually do those measurements and how to interpret the results. Also to be noted is the article Voice Intelligibility for Emergency Voice Alarm Communication Systems. This is available only in the NFPA 72 handbook, and it's written by Bob Schiaffeletti, who's a legend in the fire alarm world. It explores the broad concept of voice intelligibility and provides insights into the methods of designing and assessing intelligible voice systems. And it's certainly a good read for the designers out there. Now, one more item to note comes from the National Institute of Standards and Technology, NIST. They issue from time to time what they call technical notes. 2 of these are noteworthy, but there are more. First is Technical Note 1689 from February 2011. It's all about communicating the emergency and finding effective public warning messages. And actually, this team has done a lot of work since then to update this information. They've actually done quite a bit over the last 9 years. It discusses preliminary research findings from an ongoing project that's aimed at identifying appropriate emergency message content and dissemination techniques for various types of emergencies in buildings and building campuses in the United States. A similar technical note is 1733. It's from March 2012, and it's on developing emergency communication strategies for buildings. It addresses recommendations on emergency communication message content and dissemination strategies, and it focuses on 3 major questions. What technology exists or is proposed for use in emergency notification? What approaches are currently being used to disseminate messages? And how does the public respond to different types of information and information sources? So these and other technical notes are available for free from nist.gov. You go out there, you look up technical notes, and then there's even a search feature. You can type in words like emergency communication or loudspeakers or other similar notes and be able to find a list of technical notes that may be helpful to you. All right, our second section is going to be all about practical suggestions for improving our loudspeaker design. Now, it's important to note what really may affect system intelligibility from a voice system perspective. Now, first and foremost, you start with the audio source, which could be a person orally giving emergency instructions via a system microphone, or it may consist of a pre-recorded message. If it's a pre-recorded message, the quality of that recording, the media used to record the message, and even the type of speaker recording the message, the talker, if you will, whether they have an accent, whether they're a male or female voice, all can affect intelligibility. That audio source is then processed through the system's electronics via either a line level like an analog or a digital means, and it's delivered out to the amplifier. The amplifier then obviously amplifies the signal and distributes it via individual circuits to the loudspeakers that are out in the field. And you have the actual loudspeaker placement, and the selection of the loudspeaker equipment has a large effect on how a listener interprets that message. Now, as a fire alarm designer or even ECS designer, you often have very little input into the selection of your audio source and your signal processing equipment. It's already built into the equipment that you're using. However, you can have a very large impact on the circuiting, the placement, and equipment selection of your loudspeakers. And this is where you want to focus your time, is on these last 3 factors. Now, knowing we can have a limited impact on both signal source and signal processing, again, we want to spend our time wisely. However, if you do have any impact on head-end equipment, you should consider using the best possible equipment that you can. Now, we must next remember that we have to create our acoustically distinguishable spaces. Now, so as a quick review to what we covered several weeks ago, this is done by identifying spaces that have, first of all, common acoustic properties. Those properties include the floor. What's it made of? Is it carpet? Is it tile? How reverberant is that? Obviously, the ceilings. We're going to talk a lot about ceiling height in a little bit, but is it acoustic ceiling tile? Is it hard lid? Are there cloud ceilings or other things that affect that sound signal in the room? And of course, the walls, the glass, whether they're glass or curtain wall or drywall or something else, fabric, all of these can have a huge impact on the acoustics of the room, and thus that's how we begin to group them in acoustically distinguishable spaces. Next, we have to group those spaces with common environmental or occupancy use. We need to group things that are common, like restrooms and offices and sleeping areas and break-in conference rooms and corridors, right? Most of those have very common kinds of properties, and we can group them together. But here's some examples of other things that would affect the environmental or use properties. The occupancy load, whether there's mechanical equipment, is it a workshop or mill? Is there any existing sound sources in the space that need to be accounted for? And really, you want to identify your acoustically challenging spaces, as you will need to spend much of your time in these spaces while saving the so-called standard or normal spaces for a standard normal design. Now, some may wonder about loudspeaker voltage. I know it keeps me up at night. No, I'm just kidding. Most loudspeakers on the market have a dual voltage with options or taps to use either 25 volts or 70 volts. So which should you choose? And does it make any difference to intelligibility? Well, let's cover a few points. 25 volt circuits and loudspeakers are usually good for smaller facilities and are frequently the choice by fire alarm designers. Since the voltage is lower, the current draw is higher and often may require larger gauge wire, like 12, 14, or 16 gauge wire. And you can see in this example chart, if we had a 16 gauge wire and we had 10 watts of power on that, we could go about 450 feet. Now, that's pretty far. That's a good amount, and again, would cover most of our smaller types of buildings. However, the higher 70.7 volt systems increase the voltage, but reduce the current that's drawn and thus have a lower power loss. Thus, if you have long circuits, 70 volt would be preferable, as it may improve audio quality and thus intelligibility. Typically, you can use smaller wire as well, like 16 or 18 gauge, which is much preferable to the installing contractor. Notice in that same situation, if you use 16 gauge wire and you've got a 10 watt load, now you can go 3,600 feet instead of the 450. So you can kind of see the difference that the system brings you. Now, with dual voltage transformers, you often have more power taps or settings for the 70 volt than for the 25 volt on the same loudspeaker, giving you more flexibility for adjustments in the field. Because of the headroom, the 70 volt system is usually easier to expand more easily, like in the case of a tenant finish or something like that. But one reminder, since the 70 volt system is greater than 50 volts, the circuits may need to be required to run in conduit. Again, you can look at the listing of your specific equipment, but that may be a requirement and may help you make the decision in the cost of the installation. Thus, it's key that you decide the loudspeaker voltage that you're going to select before you design the system. Also, you will want to note clearly on the design drawings the loudspeaker voltage and the power wattage taps so that the installation goes smoothly. You do not want to go back and take down hundreds of speakers if they've already been tapped incorrectly. And I say that from experience. It happened on one of my jobs. So that's a lesson learned that I can pass on. Now, hopefully, we are ready to start our actual loudspeaker layout and design. So we have 6 reminders and/or design best practice suggestions to provide for you. The first is understand the inverse square law. The inverse square law teaches us that for every doubling of the distance from the sound source, the sound intensity will diminish by 6 decibels. Increasing the power to the loudspeaker will not change this law. In fact, increasing power may increase distortion, which thus reduces intelligibility. What you have to do is select loudspeakers with sufficient efficiency or sensitivity specifications. The higher the sensitivity or efficiency, the better. The more efficient the speaker, the lower the amplifier power required to achieve the same sound pressure level. And that can mean dollars when it comes to laying out a large system. So again, speaker efficiency is more important than power. All right, design tip number 2 is coverage, not power. Now, in order to comply with NFPA ECS intelligibility requirements, there really can be no dead spots within a space, especially if that space requires intelligibility. Of the 3 most common speaker layout patterns used today, only the minimum overlap and full overlap should be considered as part of a fire alarm or mass notification system. Now, this could mean installing more loudspeakers than your team may have been accustomed to installing in the past. Hence, the system designer will need to know more about a room's acoustics, including ceiling height, materials, and the function of the room in order to determine the best possible coverage. Again, that's kind of the whole purpose of having an acoustically distinguishable space, is to consider those very things to understand how we will design the layout. So it's important to remember that intelligibility increases with coverage, not just turning up the power. Design tip number 3, loudspeaker placement is critical. Now, it kind of seems like a no-brainer, but let's look at this in a little more detail. We don't want to rely on audio reflection for intelligibility coverage. In fact, you want to have as little reflection as possible. Loudspeakers need to be positioned and calibrated for 100% coverage at the listening height or listening plane, which is typically 5 feet above the floor. This means that the lower the ceiling height, the closer together the loudspeakers need to be placed. You kind of see that in the picture. We have the same room. One has an 8-foot ceiling and one has a 16-foot ceiling. And you see that listening plane, which is about 5 feet above the floor. The lower the ceiling, the more speakers that are needed to provide that uniform coverage in the loudspeaker's cone of coverage. Whereas the higher speaker, we get more coverage and need less speakers. So we need to make sure that our ADS definitions include a close consideration of ceiling height, which will drive your loudspeaker placement in your design. So yes, loudspeaker placement is critical to effective coverage of your system. Now, design tip number 4 is to further understand that listening plane or listening height that we just talked about. Now, not surprising, the edge-to-edge speaker pattern that we showed a moment ago is popular with paging system installers because it's the most cost-efficient, the least labor-intensive solution to install. But it's worth repeating that this same edge-to-edge pattern may not comply with today's NFPA intelligibility standards. You need 100% coverage at an average 5-foot listening height with no more than a 6 dB loss from each source to maintain that intelligibility. Minimum coverage or full coverage approach, both requiring loudspeakers to be placed closer together, is your smarter and safer solution. In difficult situations, we need to attempt to strike a balance between what we call the nominal and effective coverage angles. In the graphic, you see the effective coverage angle is a 90-degree triangle, and you can again, we're measuring that at the listening plane. That's where we'd like to be. But practicality can sometimes demand otherwise, and so we have this nominal coverage of 120 degrees. So that's really striking the balance between perfection or optimal and reasonable or acceptable. And really, there's no other way to say it, but intelligibility requires effective and balanced coverage. You're not going to be able to do perfect in every single scenario and in every single occupancy or room, but you really want to, this is kind of what you're playing with, is this difference between effective and nominal and the coverage you're going to get in the room. Our fifth design tip involves wall-mounted loudspeakers. So far, we've been talking a lot about the ceiling, so we wanted to spend a little time on wall-mounted loudspeakers. There's many advantages to using wall-mounted loudspeakers, especially when retrofitting a system or perhaps converting an old Hornstrobe system to a voice system. Note some of the advantages that we can see. For corridors, fewer speakers and less amplifier power is needed. We commonly use wall-mounted loudspeakers in corridors. Depending on where we place that loudspeaker, particularly if it can be on the end of the corridor, pointed down the corridor, that can be a very effective way to cover a corridor with using as few of devices as possible, because it improves the distribution of the direct sound to the listener. Wall-mounted speakers put sound directly into the listener's area, and that can be very effective because it reduces the reverberation, and we can use more than one wall to do that. And we can use combination speaker strobe units with the installation of one appliance, and this is probably the biggest reason we do it. Unfortunately, often we place that combination speaker strobe unit according to the rules of the strobe placement or the strobe layout rules. And we often forget that the loudspeaker layout needs to also be addressed. We do have some disadvantages when it comes to wall-mounted loudspeakers. The sound field from wall-mount loudspeakers is more likely to encounter obstructions from furnishings such as cubicle walls in an office environment or movable partitions in a conference room. If the furnishings in a room are likely to change, a distributed overhead system or a combination wall mount and overhead design should be considered. This minimizes the variation of audibility and intelligibility. In rooms with low, hard ceilings, the sound emitting from the top hemisphere of the loudspeaker coverage pattern is reflected off the ceiling and down to the listener. This can increase the reverberant field sound level and results in either a delayed arrival of sound or a distortion of that sound. These factors both contribute to a reduction in intelligibility. And we'll look at a new device that actually changes this a bit at the end of our presentation. Finally, when selecting locations for wall-mounted loudspeakers, you need to calculate the loudspeaker distribution a little bit differently from ceiling-mounted appliances. Again, let's look at a few tips on how we can do that. The design of a distributed wall mount system is similar to an overhead system, but there are some important differences. In a wall mount system, the speaker to listener distance depends on the listener location in the room. Therefore, the audibility calculations must be done with the listener at the farthest distance from the speaker. Now, in rooms with speakers mounted along a single wall, the farthest distance is calculated at 3 feet from the opposing wall. So you kind of see that room depth becomes a very, very big factor. And this is why in a corridor, mounting on the end of a corridor and coming down that corridor can be very effective. But if this was a 10-foot corridor, this is not a very effective use of that loudspeaker in the room, because then we're only 7 feet away from the device when we're measuring it, and it has a very small access of coverage that's there. Additionally, in general, wall mount speakers are located between 80 and 96 inches above the floor because we're trying to match the strobe layout. And this nicely matches those requirements, but we need to keep in mind how that will affect the movement of sound in that space. Now, the coverage pattern for wall mount speakers are somewhat the same to an overhead system, but the goal is the same. You want to minimize the sound pressure level variations in a protected area. But instead of thinking of the listening plane, that distance 5 feet off the floor where we're trying to balance the sound there, we look at the room width minus 3 feet. And so the depth of the room and the throw of the loudspeaker becomes the critical issue. In a wall-mounted system, it's generally more appropriate to consider the diameter of coverage rather than the coverage area. The coverage diameter defines the width of wall coverage and ultimately the speaker spacing, depending on the coverage overlap pattern like we have here. That could be very effective, providing a full cone for each loudspeaker, in this case mounted on separate walls, to provide that uniform sound throughout the space. Now, the preference is always to use a single row pattern when designing wall-mounted loudspeakers. Even if the room is quite large, you would still want to do like what's shown in the drawing, a series of wall-mounted speakers all facing the same direction. And again, whether you're using an edge-to-edge, a minimum overlap, or a full overlap, based on your specific situations, you want to all be facing them in the same way. And really, the tighter the spacing pattern, the better your intelligibility is going to be, depending on where you draw the line between that minimum overlap and full overlap with a cost consideration. And really, rooms greater than 20 feet wide should not really be treated with a single wall of loudspeakers. We have to remember, this is not horn coverage. We're not putting a bunch of horns on one wall and just blasting noise to get people out. We're really trying to communicate. So in rooms greater than that, we need to think about a row of speakers, or again, possibly moving to a ceiling mounted distribution. And we would never want to aim two wall-mounted loudspeakers directly at each other. We always use an offset pattern. So you can obtain intelligibility using wall-mounted loudspeakers, but you have to understand the little idiosyncrasies or differences between them and the ceiling-mounted. Now, our last design tip is to apply the correct amplification or power. After the loudspeaker layout is complete, the design should be overlaid with the notification zone. Now, your notification zone may be a whole floor, or it may be a subdivision of a floor based on the fire and smoke zones, but you must coordinate them as the designer of the system. Remember, an individual notification appliance circuit must never extend beyond the boundaries of a notification zone, and that's a direct requirement of NFPA 72. Then you need to select your loudspeaker wattage for each appliance and design your individual circuit pathways. Applying the correct amplification to power each of the loudspeaker circuits in the design with a safety factor for future expansion, or to adjust to any additional speakers that might be needed due to construction changes at the end. Generally speaking, a 25% safety factor is recommended unless you have a future tenant finish space or some known space that needs to be specifically accounted for, and then that safety factor may be much higher, or you may reserve one or more circuits entirely to be reserved for a space like that. Now, obviously, the amplifiers should be designed to work with the chosen loudspeakers. They may be centrally located or distributed throughout the building as needed and as allowed by your system's infrastructure. Again, if you were to actually use non-listed speakers or speakers that aren't matched to your amplifier, then you're going to have to find the correct amplifier to power those kinds of situations and account for what's required. The designer should specify the power output and the cooling capacity that might be needed for each amplifier. And remember to check the specification requirements for backup amplifiers. Sometimes that is missed. So proper NAC circuiting design, power and wattage settings, and amplifier selection and placement all improve intelligibility. Let's finish up with section 3, which is all about new technology in loudspeaker design. Now, fire alarm systems, tone-based fire alarm systems, and voice fire alarm systems have been in active use for 40-some years. The existing inventory is staggering. Many continue to work quite well, while others have been replaced or need replacement. Over the last 5 years or so, we've seen an influx of voice systems from various manufacturers and in various varieties. However, other than the switch from analog to digital processing equipment, much of the head-end equipment has not changed. The majority of systems on the market today have signal processing equipment and amplifiers that might not have changed in many years. In some ways, this is true of loudspeaker technology in the fire alarm and ECS industry. However, technology improvements, or perhaps better said, technology expansion from the commercial world to the fire alarm world has resulted in an increase in intelligibility options available to fire alarm and ECS designers. Let us look at some of these items that have contributed to these technology improvements. Now, over the years, there are some commonalities between fire alarm loudspeakers from almost every manufacturer. Using a 4-inch speaker, a paper speaker cone, is cost effective, and it places the loudspeaker in a much smaller package. The loudspeaker can usually be installed on a 4-inch box or 4 11/16 back box with or without an extension ring for ease of installation. Usually 2 different voltages are available, like we talked about, 25 volts or 70.7 volts, to allow some universality with the chosen amplifier and the wiring length that might be required. The frequency of the loudspeaker is almost always that 400 to 4,000 hertz. Again, this was historically based on fire alarm horn tones and not necessarily based on human voice frequency, as we discussed earlier. Now, power is usually provided by 4 taps from 1/4 to 2 watt, but occasionally extends from 1/8 of a watt up to 4 watts in 8 steps of power. But again, just kind of depending on the manufacturer. Again, the 25 volt options may be a little bit different than the 70 volt options, even on the same loudspeaker. Additionally, all UL listed fire alarm loudspeakers are built understanding that a supervisory voltage will be monitoring the circuit integrity of the loudspeaker circuit when the circuit is not in use. This is usually done with a blocking diode or some other technology, and it marks a significant difference from commercial audio speakers, which is why the two are not interchangeable on the same circuit. So what is being done to change the status quo of fire alarm loudspeakers? Well, first, we see a movement from regular to high fidelity loudspeakers. Now, this is significant and highly important. Moving from regular to high fidelity involves increasing the speaker frequency and really its sensitivity. In most cases, it expands from that 400 to 4,000 hertz range to 300 to 800 hertz, or in some cases, to 200 to 10,000 hertz. Keep in mind that a large portion, about 30% of the human speech zone, is above the 4,000 hertz range. Now, all of this is done while continuing to use that 4-inch speaker cone and then keeping that small real estate that's required and maintaining all of the other speaker power and voltage options that we just talked about. Now, some caution is appropriate in this regard because the term high fidelity is often used as a marketing term and may reflect so-called high fidelity at a certain frequency, like 520 hertz. And it may not indicate an increase in the actual full frequency range of the loudspeaker for human speech. You need to check the loudspeaker data sheet for the details. The JCI loudspeaker that you see on the screen in the center is a great example of that. It actually does greatly increase the frequency range. I think it's the 200 to 10,000 hertz range. It's a much better speaker. It performs much better in the field, and is worth using for a huge variety of loudspeaker installations. Now, another technology improvement is the increase in loudspeaker size. Moving from a 4-inch to an 8-inch loudspeaker cone creates a better bandwidth performance and thus increases intelligibility. The larger cone increases the loudspeaker's frequency response that can deliver the 7 octaves of human speech much better than a 4-inch cone can. With this improvement can come additional power taps on the loudspeaker, providing greater flexibility in the field for fine adjustments. Obviously, an 8-inch loudspeaker will take up more real estate than a 4-inch, but the intelligibility increase may be more than worth it. Also, these larger loudspeakers may only work at 70 volts sometimes, or even higher, so you may have some considerations to make with your amplifiers and your circuiting itself. Now, here's an example of an expansion of technology from the commercial world to the fire alarm world that I like to call it's hip to be square. They basically took a high quality 8-inch loudspeaker cone and they placed it in a 2-foot by 2-foot molded fiber enclosure with a powder coated steel baffle and listed it for fire alarm use with UL. It's available in 25 or 70 volts with 5 power tap settings. It fits perfectly in a 2-foot by 2-foot or a 2-foot by 4-foot wide regular ceiling tile grid, and makes for a great replacement speaker, especially when converting systems from a horn-based system to a voice system like we see in our schools, our K through 12 schools that require this kind of expansion. Now, if that wasn't enough, they have an optional version that has a pre-wired electrical box at the center of the tile so that you can add a visual notification appliance, a smoke detector. You can even add a camera or some other device right at the center of the device. And this is nice because no need to cut anything or provide anything. Everything is lined up. You can have devices that are speaker only, and then you can add the strobe where appropriate. It makes for a very nice, clean installation. This is a little YouTube video about them installing one. I'm not going to play the whole thing, but this is a Quam speaker. It's made in Chicago. You see it weighs about, I think it weighs about 8 pounds. It just pops up into the ceiling tile. The installation time is much shorter than it can be done in with a ceiling, a normal round ceiling speaker. That's the key, is there's no ceiling tile cutting. We don't have to cut. We don't have to put in a tile bridge or any of that. It's simply dropped in and the speaker is wired up. The speaker also includes 4 seismic tie-off points. This was a question that came up in an earlier session, but in this case, they're hanging it directly from the ceiling grid for an example purpose. But there are 4 tie-offs that you don't see. They can be tied off to the actual structure so that they're not being supported solely by the ceiling grid. In using the latest loudspeaker technology, it'd be appropriate to comment on our outdoor loudspeakers. I know a lot of you may not design wide area mass notification systems while using outdoor speakers, but I wanted to show you the variety of what's available. Now, these are 4 major manufacturers of outdoor loudspeakers that are on the market today. You might recognize some of them, or maybe even use some of them. But I just wanted to show you the huge variety, both in the look and appearance, but also how you physically install these things. I mean, in most cases, these loudspeakers are providing, as you see, about 70 to 74 dBA at a half a mile or more. And some of these loudspeakers, or HPLAs, if you will, provide very intelligible, very intelligible voice at that distance of a half mile or even greater. But notice the huge difference in the size, ranging from just 26 inches high and 50 pounds to some 100 inches high and others at 320 pounds. So you've got to take all of this into consideration, because obviously when it comes to mounting any of these devices, you've got to figure out how to mount those kinds of things with that kind of size and that kind of weight. And really, the loudspeaker is just part of the picture. A designer must consider how you would power and trigger these devices, what equipment cabinets are available, and where must they be placed, what primary and standby power is required for the control equipment. And again, some of these product lines are more complete than others, but a designer needs to weigh all of these options. So just showing you all the different varieties that are out on the market. Now let's look at some newer technology that can be used indoors that you may or may not be aware of. But really, with many of these are focusing on intelligibility, size, and sensitivity. And we've hit on all of those things as important factors to intelligibility. One such device is produced by Ultra Electronics. I think they're in the St. Missouri area or Columbus. I forget where they're at. This is their Hyperspike line of products. And we're going to look at a few of those because I think they're great examples of thinking out of the box and being a highly intelligible line of speakers. This particular one is the TCPA Omni. It's a 360-degree omnidirectional speaker. It operates at 70 volts with 3 power settings. It weighs just 19 pounds, so it's very easy. You can see in the picture it's hung by a chain, basically. It comes in 3 different colors, and of course, fire alarm red is one of those. You can have the word alert written on the bottom in the case of mass notification systems. You can also have fire if they were just used for fire alarm systems, or no writing at all, any of those options. This has a 0.85 STI score. That is an incredibly intelligible speaker, can really provide great coverage in any of these applications: manufacturing, warehouses, hangars, any other large assembly kind of spaces. Very usable. This provides 70 dB of sound pressure level at between 650 and 1300 feet. Depending on the wattage setting that you're using. So very reliable. Think of the cone of coverage kind of like that umbrella we spoke of. It kind of cascades down. A very good device to use in our larger spaces in particular. Now, we have a little case study. I'm not going to go through it, but this was a huge, a 450,000 square foot manufacturing facility that had been laid out with kind of a typical 15-watt horn cluster layout. But they took a look at this and said, what could we do differently? And you can see by going with a better technology speaker, they significantly reduced their labor and installation material. They had a lower requirement for battery backup, just the whole long time maintenance savings and better intelligibility. In fact, when you do an ease modeling study of this same space, you can see the difference in the sound pressure level coverage between the 2 layouts. This is the cluster speaker, and you can see you got all these little pockets of red. That's where you have the loudest sound pressure level. But look how smooth the coverage is with the omnidirectional speaker. Really makes a huge difference, and you see a much greater distribution of sound pressure level throughout the space. A much better use of funds. In a similar way, we have a small version of a 360-degree omnidirectional coverage. This is kind of in a hexagon format, square to hexagon, but in a very small package. This is a 41-volt speaker, so it requires a transformer in order to connect to a fire alarm panel, but they have that available. It's 650 watts of power. It can provide intelligible voice over a half a square mile radius or range. A very powerful speaker, and it weighs just 20 pounds. It's Class 1 Div 2 certified, and it is fire alarm listed UL 1480. It's used really anywhere, but particularly in outdoor spaces, campus open spaces, athletic facilities or parking lots, even parking garages can take advantage of this. Even in temporary alerting situations, this is an example from Florida where they put it on their mobile command vehicle. They can set up at protests, they can set up at block parties, at tailgating situations, if we ever get to do any of that again. And it can be used for mobile alerting and temporary alerting for festivals and events. Very, very powerful little device. This is another item from the HyperSpike line. This is called a TCPA 10. It's probably their most popular speaker. Again, has a lot of voltage ranges, a lot of power settings. It weighs just 9 pounds. It is Class 1 Div 2 rated if you need that. Very, very good for really all environments, but particularly high ambient environments or manufacturing or parking garages. I've demoed this particular speaker in a parking garage, and it is amazing the difference between a normal cone speaker and this device. It can also be used in stadiums or large assemblies with different mounting options and directional aiming. And if we do an easy vac model of this kind of gives an idea. But what I wanted to highlight on this is notice all the speakers are still pointed in one direction. We're using those rows of speakers. I probably would have done this layout a little bit differently to provide a more uniform coverage, but you kind of get the idea. And the key is this is a hyper intelligible speaker. It's so much different than the typical cluster speakers that we have out there. Really a great speaker that gives you a lot of options. And one final thing to note, we have a totally new device to the fire alarm and ECS industry. It's used, we want to use it specifically for reverberant environments like atriums and any place that's hard to those acoustically challenging spaces we talked about earlier. And that's a line array, or what they call the line wave. It's also made by HyperSpike, which is Ultra Electronics. They call it the line wave, but it's the first line array speaker that's been listed for the fire alarm industry. Depending on the model you pick, it weighs just 3 to 15 pounds. Just a huge amount of options that can be used. Power from 20 watts up to 200 watts. Even as small as a 2-speaker array versus or 4, 8, or 16, and you'll see those in a moment. Now, this is perfect again for things like parking garages, airplane hangars, airport terminals, anything with a lot of people, gymnasiums, atriums, but large conference centers, large office spaces, even corridors and tunnels. And you can kind of see the options that are available based on the size of your space and your requirements. This comes in, I think, 4 or 5 different colors. You can kind of see a sample mounting of how they did it in this particular instance. And really, it works by controlling the vertical dispersion of the speaker. So rather than having that conventional speaker, particularly a wall mount speaker, where signals are bouncing off the ceiling and down, bouncing off the floor and up, creating distortion and reflection, it puts the sound where it's needed the most, and that's at the listener's ears. It's the definition of providing sound at that listening plane that we talked about. And again, it doesn't put sound where it's harmful to intelligibility. A real benefit to the industry. So the question is, what will you do differently? Remember a few points. We want to understand the code requirements to provide intelligibility for your design. Some of those are in NFPA 72. Some can be obtained elsewhere. We want to apply the 6 design tips we gave for improving loudspeaker designs. I think it will help. And use the best, most modern technology for improving intelligibility where you can. It may cost a little more, but in the long run, you're going to be more satisfied with the results and provide a better solution for your clients. So with that, I will bring it to the question period. Anne Marie, I'll throw it back to you. And if there's anything you want to, any questions in the queue?
Sure, there are no questions in the queue, but I will wait a moment here to see if anybody does have a question. If you'd like to type it in or you'd like to just open up your mic and ask, that would be great. Doesn't look like anyone is, so I think that we're probably all set. This has been recorded. We will be posting it. It will probably be about midweek next week as we do a little editing to it in terms of branding and so on and so forth. I will also get a copy of the presentation out as some people have requested it. And at this point, I'd like to just thank Larry very much. This was a great presentation. There's a lot of interesting information that was shared, and it's greatly appreciated that you take part in this program with us.
Thank you. Pleasure to be a teammate.
Thank you, everyone, for joining. Have a good day.